Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to look at another tool for doing dynamic analysis of unknown binaries, and this tool is called ltrace. Now, we discussed strace for system call tracing, and ltrace is very similar, except it will trace library calls. So we'll go ahead and start with our bind shell, and just like strace, you just run ltrace and you give it the name of the thing you want to run. And you see this one was pretty quick, called libc start main. And here is where the program started. It called malloc, and it allocated 257 bytes of memory. It then set all 257 bytes to 0, to a null. That's what the \0 tells you. It called put car on this memory address, and it put 10 zeros into that address. Then it called Python, called popen on Python, got the version, called fgets on Python, a child process exited, and it says fgets resumed, stir, not found, calls fork, and it exits. So that was all of that shell. We can do something similar with the root shell. And remember, as before, it gives me the wrong password. Right, so here we see what it did, called main, allocated 18 bytes, set them to 0. Then it printed a string. In this case, it was a null string. It did a comparison of that null string to this guy. So it's hard-coded this password of SW0RDM4N. It put string, it printed out wrong password, which you can see right here, and then it exited. So let's rerun this time using the correct password. Now you see a different behavior. Once again, main, malloc, memset. Now it does an snprintf, does a comparison, and it says, oh, those are the same. Calls dupe on 1337, very subtle. And here is address for some code, makes a system call, and it's done. Now let's try our last binary. We'll do an ltrace on Xingxi reverse shell. Once again, it's going to complain and say, hello, you don't have the correct usage. And it's going to exit. Let's rerun that with an IP. And now you see it calls main. For reasons unknown, it calls string length a bunch of times, calls fork, and then exit. And it also says, hey, I failed to connect. So that allows us to get some basic information on what libraries and library functions are being used in these functions. Now, again, a warning, we have not controlled the execution path. As we saw in the case of the root shell, if we did not supply the correct password, the execution path wasn't the normal one, and you won't necessarily be able to figure things out. But again, we have yet to start digging into this code. And just by running a couple of simple utilities, we've been able to get kind of a feel for what's going on. We can see what system calls are being made, what library calls are being made, and that gives you a lot of information without having to know an awful lot about assembly and other low-level items. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.